Let's see if it'll engage again. Let's see if it will engage. Okay, so I'm going to engage here. It's at 211, 210. Okay, so that should be fine. So add filament. Filament should be coming down that nozzle. And I am adding here. I can see the gear moving on the feeder. So the gears are right up here. If you look at the gears, we can see that that's moving. But there's no filament coming out. Oh, there we go. Yeah, so I think this is for some reason it's pulling the let me just extrude a little more so the film is well seated into the okay, now it's having a little bit of a hard time, I think, extruding. Let's see, because I do hear some noises there. Okay, so that should be extruding just fine because it is coming out. One more time, add filament. Okay, it is extruding. Okay, so with that said, get this little booger out of here. That's done. I should be able to just print just fine. So 27, 270, 210, print. Give me that part again. Confirm. And that should start printing just fine. Now it's dropping filament. I hope the little string that is on the side does not mess up my print here. That popping sound that I hear is from this plastic sheathing here. Okay, it looks like it's dropping. It's a very thin line. Now it's going through the second layer on that perimeter. It's dropping a second layer, and that should not create any stringing or deviation from that pattern there if it's right on top of the other one. Okay, looks like it is so far. I'm making very small adjustments here to the table, so it brings that back a little bit higher because it was a little bit loose during my leveling. Okay, now it's going through the third layer, and it looks like it is dropping it right on top of it. No deviation, as it should be, and no deviation in no shifting in layers. That means the one is on top of the other one. Okay, now let's look at these little guys, which are these little kind of washers, colors that I print for my. Okay, so far so good. Just laying it just right on top of it, the way it should. And there's a little bit of a gap between the nozzle and the table, but as it drops the material flows right into the hot bed, which is set at 70 degrees, and that should be able to hold those parts. Also, the extrusion is being extruded, the filament is being extruded at 210 degrees, so that's dropping it nice and toasty. And that should hold. I mean, that should give a nice layer. But I have to go through this all these steps in order for these things to print right. I mean, it's a little finicky as compared to my Anycubic i3 Megas, which are they're almost, my Cuba Guy 3 Megas are very, very precise machines. Of course, you have to level the table, make sure that that's all level and fine. But once the layers, once that starts to drop the material, it's very consistent. It remains on the table without shifting or without lifting or without curling up. So we'll see what happens. I'm running this at the standard sliced feed rate, which is set at 50 millimeters per second on my slicing software. So it looks like it's dropping it this time. It looks like it's doing its thing the way it should do it. And maybe before I just needed to clean the bed or maybe make some finer adjustments. But it is retracting the filament way beyond its point, and that's not good. Before it starts printing, the filament, it gets so much retracted that when it starts the print, unless you force the filament, as I did previous to this print, unless you manually extrude manually to the point where you know for sure that material's coming out. Unless you do that, the part is not going to start printing as we showed in this video before this print. It just started going around the geometry with no filament being dropped on the table. So now it looks like it's doing its thing. I mean, it's a great looking machine. I mean, I really like the structure of this machine. It's a solid machine, and if this could print with more reliability without having to go through all the steps that I went through before getting it to print to this level so far, it'd be an awesome machine. So it is those things that I need to. Unfortunately, Trees has not been very responsive to their after sales support. I had an issue with my one of my Lure Plus machines, and they're sending me some replacement part. When I asked about that part, they didn't give me any information. There's no record of that being sent, and I cannot talk to anybody there. Nobody's around. If you go to the website, to Trees website, via chat, they don't give you too much information. They tell you, go to the after sales support, and that's really useless because nobody's responding. I send them what they respond is they respond with with a copy of what you said through their chat. That's not an answer to the questions that I've been asking. And similar with this machine, that's why I'm making these videos, and that's why this video is a little bit long, because I want to capture it from start to finish if I can. I don't think I'm going to be sitting here 6 hours for this part, which is a group of parts, small parts to finish, but I do want to see the first layer, at least how this is laying it out. So I think if I can get through the first layer with consistency, and you can see those little tiny parts there, and this should be fine, provided the bed is level and the machine is doing its proper feeding of the material. Because if the material is not being fed properly, we're going to have the issue that I had with the first print of these things being layered like that. But I think this had to do with not only with the tightness of this feeder mechanism. This was loose, by the way. After I tried to find out the reason for this, I looked at that part, that screw, and it was loose. So I think it had to do with that, in addition to the slicing software not being properly sliced, and that's because I'm using that new Cura slicer software that they send you with these machines, and my older Cura's slicing software just works fine, with my Anycubic 3 Megas. And so I resliced that part, and let's see what happens here. Okay, it's first layers are looking okay. Okay, it's layering that first part, that my logo there. That's a little part that I include, for the canopies that I attach with that little bracket right below it with two little screws that goes on the canopy, and so that gets so I'm just letting it print at a regular speed of the sliced file. I'm not even increasing the speed here. This machine is supposed to be able to print really fast, but it's very important that these parts get laid out properly. First layers is very, very important. Once those parts are nice and solid, as we're looking here, this time it's really printing very, very well here. But I had to go through those steps as we saw in this video here. And do I need to do all those steps, before each part that I print? I don't think so. My Anycubics, I don't have to do that. Once the machine is set, one time, that's it. I can come back, hours or days or weeks or months, even later, and just hit print, and it prints with the same consistency. That is the true measure of a good machine, when you can do that with consistency and repeatability. So far so good. This is actually the first time I'm seeing these parts being laid out that well. But I still don't trust the display because it was doing some funky things there. So I don't know if that's an issue with power supply. Maybe the power supply is not grounded properly, because I did come across some video or a comment that said that the power supplies are not grounded to the structure here, which typically all machines that are made out of metal, they need to be grounded, because of possibilities if for some reason one of the leads or the power leads becomes loose and makes contact with the metal structure. You want that to you want to establish a short path to ground, and the only way to do that is to ground the machine to the metal surfaces. That's typical with any machine that's metal or equipment that's metallic. It's just from a safety standpoint, so you don't touch the machine. If it wasn't grounded, you would touch that. If one of the hot leads is touching the metal, and you would get shocked. So that's one of the reasons why the machines need to be grounded. And I'm sure people that know, that understand electrical circuits know that already. But I'm just throwing that out there, for those that don't know. And so I need to hopefully this part will run just fine. It'll complete, and then what I'm going to do is open up the machine again, or open up the bottom, and double check all those connections. Make sure that I did check kind of a quick inspection of the bottom underneath when I assembled the machine, just to make sure that all the wires were they seem to be nice and tight. On one of my on my Bluer Plus, I had an issue with the black wire that goes to the black wire that goes to the 24 volt output to the bed. Almost caught on fire, and it's kind of scorched the connector. There's a black residue there because the connector was not properly seated via those screws of those connectors. You insert the wire. The wire had a proper termination. All the stranded pieces were attached with a just a metal what are those called? Those little sleeves, just to contain the strands. And so that was inserted into the connector just fine. But for some reason it had come out loose because the screw was not tight enough, and so that was creating a spark. Because when there's no true connection there with the distribution of the power, you're going to have a very very small contact there, and that's if the bed is asking for a lot more power to heat up the bed, that's going to heat up. That very small contact is going to heat up to the point where it's going to heat up, the sheeting. That's what happened with that wire. So a machine can potentially catch on fire if those things are not properly set up, and that's what happened with my blower plus. I pointed that out to Trees. I sent them a video. I sent them like I was saying earlier, send them emails. They're not responding to my emails with a solid answer. I just got a response from their chat that apparently they're sending me a replacement part. What part are they sending me? I asked them what part are they sending, what's the tracking number. They didn't provide that information. And so that's also where a good company stands out. Technical support is very very important. I also manufacture products, and not 3D printers, as I've said in many of my videos. You can see the stuff that I produce on my YouTube channel and on my webpage. But technical support is very important. I provide all that stuff because I'm the one that designs, I'm the one that manufactures, I'm the one that does all those things, and I also do marketing and customer support as well as my website. So I do all those things, one man type thing. But customer support is key. When people can't assemble them, proper instructions is key. But also technical support is very very important. After sales, you don't want to leave the customer hanging when he runs into issues with the product. If the product requires technical support, that should be a priority, with companies. But they don't. Everybody's more interested in selling these machines and cranking these as fast as they can and just getting them out. You don't build longevity in a company without proper technical support and assistance to customers. My company's been around for 23 years. So if that says anything about the way I operate my company, granted, sometimes things are not as perfect as we would want them. I am very conscientious about those things, those details. And customers eventually will understand that, and they'll come back to you because you provide that level of service. Okay, let's see how those parts are doing in the back. I'm gonna have to come back here. Okay, so it's laying the first layer quite nicely this time. So if this keeps going layer after layer after layer, these parts should come out, very very nice. Although there is, like I said, there is as this is traveling, there are some little areas where little bumps that this mechanism is experiencing as it travels XY, and I believe, as I was saying earlier in my video, I believe that has to do with the pulleys, the timing belt pulleys, which are installed on the motor. So if one of those screws, there are two set screws that it does have a flat, as we can see from here, that those stepper motors do have a flat where the grub screw or the set screw can engage one of them, and then the other one is just for additional security. There you go, the flat. So, but if that timing belt pulley is a little bit off, it's going to throw off the precision of the travel on the machines. How do I know that? Because I've seen that in many of these pulleys that are made out of plastic. So I don't know if those pulleys are made out of plastic, injection molded, or if they are metal. The metal aluminum ones tend to be a lot better. I would imagine that they put aluminum pulleys here in this machine, given the type of machine that it is. I mean, if they're giving you linear rails, I would imagine that they're also giving you metal timing belt pulleys. I don't think those are plastic, as on some of the cheaper, really cheap machines. But I believe it may have to do with the set screws. maybe one set screw is not too tight, or maybe it's a little bit off concentricity with the shaft of the motor. So it's there are some little bumps here that I noticed that when I was running this machine, doing some test parts. And as we can see on this part that it printed, I'm going to focus in a little better on this part so we can analyze this. And this is this is the block that they give you in the file. Yeah, you can see that. You can see, and on one corner, I believe it's on the. As this prints this way, it's on this corner right here that I noticed some parts were coming out really uneven. I mean, I could live for, because my parts are not that high, that tall, and they're kind of small and shallow. I could live with that surface on some of the parts. It's not going to affect the mechanical assembly of these parts where they go in. But right here, you can see that right there. This is the corner. There's ghosting, and there's a right there. That's those bumps that I was talking about. You can see that in that section right there. See how it's concave in that corner? That should not be concave. It's because the tool or the print head is shifting. It's kind of going through a little what I called a kind of a pocket or a sinkhole during the travel, the X and Y travel, and that is probably the other reason for the. That's probably the same reason for these layers coming out. Doing that, there's a little bit of shifting layers here. It's not precisely one on top of the other. This has to do more with that Z-axis, because as the layers are going up, or in this case down, the bed is going down through the Z-axis. So the Z-axis is a little wobbly and not precise. It's going to shift. That lead screw is not precise. It's going to do that. So I would not. I would imagine that these lead screws are not. They're providing a little bit of a sway, left and right as the parts are printing, as the layers are being layered, So the lead screw is not precise, is doing that. These are the screws that they tell you not to tighten too much to allow this to allow this to calibrate, because when you have a machine that runs on linear rails, it has to be super square if you want things to work precise. That's the only thing with linear rails. I mean, it's great, very smooth, but everything's got to be very square. So one thing I didn't do is put a square on these posts here. So I'm going to do that once this part is. I'm just going to let this part run, and then I'm going to put a square and level and see where we're at with this assembly here, because I just follow the assembly instructions as they tell you to do it. The other thing I noticed is this right here, this label. It's not a big thing. This label should have been 180 degrees inverted like that. So far these parts are layering the first layer. I would say quite well so far. There's no lifting on this. There's no lifting here, but ooh, what's going on here? This area right here, there are parts that go there. I wonder if those parts are. Maybe it'll come back from that point over here and finish that first layer on these other parts that belong here. We'll see how that happens. Yeah, these parts are small, but the table, in order to do a bunch of parts like this, and again, that's the reason why I bought the Anycubic i3 Megas, and I've been using those for the past 7 years, because although those machines have a smaller footprint, you may ask, then why are you buying these machines if the i3 Megas are doing just fine? It's because of the footprint on the Anycubics. This is, the Anycubic i3 Mega the edge of the bed is no more than a quarter inch away from these edges here of all these parts. So it's I mean I'm maximizing the print of area on my Anycubics by putting all these parts, as many as I could put. And this is a whole kit for the MIA Easy 1.0 RC Microlight. That's what all these parts are for. And actually, this is, I'm trying to print this for a customer that ordered this particular kit recently. I mean, I have some other orders that I was going to print, but I was hoping to let this part run on this machine and see how it does in terms of speed. The other thing is that these machines are also supposed to be a lot faster than the older machines. I mean, this machine is set to run at 300 millimeters per second. I don't, you know, manufacturers tend to elevate, you know, those specs a little more than what they truly are. You know, in order to sell the machines, I understand that. I don't do that with my products. I like to be as honest as I can with my products. I mean, what you see in my videos is what you get, provided, you know, you have to set it up right and correctly, like everything else that is built from a kit. But, you know, for this to run at 300 millimeters per second, everything's got to be very precise and calibrated. I don't think, I mean, you could run it, I suppose, at those speeds, but even this is a little too fast for the first layer. But I'm just letting the original settings and the basic settings do their thing here. That's why I'm not changing that. I mean, I could slow the machine down to below the 50 millimeter per second as I have set on the Cura slicer, but I just want to see what the machine can do in its stock settings with the files as I run them on some other machines just fine. But so far it's fine. So once this layer is done, I mean, this is giving me a little more confidence that these parts are probably going to print just fine, given that, considering that my previous parts were, I mean, I have two attempts here. The first attempt was this botched up all these layers. They were like really spongy and really weird. That was the first attempt. The second attempt, you can see these parts, they were lifting. My second attempt, I had to pull it at I don't know, 3-4 layers height, maybe 2-3 layers height, because these parts were curling up. And I tried printing this at 60 degrees Celsius on the bed, and that's the reason why I increased this to. I increased these parts to. Oh, it didn't complete. It did complete that section right there. Now it's going again around the perimeter. Why is it doing that? It's going around the perimeter again. That's not part of my geometry. I don't know why it's doing that. Huh. That has to do with the slicer file. And then I don't know, maybe cleaning the nozzle. Maybe it goes around to clean the nozzle. Now it's doing the second layer on the parts. But as I was saying, these the second try, this was lifting, so it wasn't grabbing onto the bed, and that's the reason why I increased the bed on this run to 70 degrees, and it seems to be holding. So maybe that's the trick with this machine, that I have to run it at 70 degrees, or put that ugly mat underneath, that insulator mat. So I'm going to pause this video and come back to it when the second layer goes through, and from there I guess I will pause the video permanently and do another video to show the completion, if this ever completes. But so far it's looking good. Okay, the second layer. Let's see if we can zoom in on these parts right here. Second layer, as we can see, that little string there, these little strings right here, and it's on both of, all four of these corners here. These are the corners that I use for my seats on these mini RC microlights. I don't know if that's just a machine kind of going from one point to the other one and kind of dragging the filament. Maybe it was dripping a little bit there. Maybe it didn't retract it all the way as it's going from one point to the other one. It seems to be consistent. And there's that long one there, there's another long one here, and there's that vertical and vertical there. So I don't know, maybe that's what that is. The other parts are coming out nice, second layer. So I'm going to let this run. Let's see if I can, where is that? Looks like it's working. So my concern was with these little guys right here, these posts right here, those and these, because these are little tiny parts here that those need to be perfectly printed. The rest, these are just plates, you know, for the frame. That's my my cross control there. This is a battery support plate, and that's coming out really nice. That logo there. That's just a little frame with my letters there in my microflight. These also came out so far so good. Second layer on these. These are my collars, little tiny collars, wheel collars that I use, and these are just washers that I use for my wing, just to reinforce the corners. Those are clips that I use for the carbon rods. Those need to be printed a little bit higher there. Those are my servo plates. That inside is a battery support, which is what that part is there. That part right there that needs to be a second layer. So my servo plates are coming out very nice so far. And my motor mount is this part right here. That's the motor mount. That's going over the motor mount right there. But there is a little bit of a deviation there. That you can see those lines there inside the circle.